Hi, I'm Humberto Zarzosa, and today I'm going to show you the 3 Newton's laws of physics. So before getting into the laws of Newton, we have to first know two basic concepts of this topic, which are mass and force. So force is basically just a vectorial physical quantity which measures the intensity of the interaction between two objects. And then there's also mass. The mass is the amount of matter that an object possesses, or it can also be defined as the scalar physical quantity which measures the resistance of motion. So for this topic, we're only going to use certain types of units. For example, for the force and the weight, we're always going to use newtons, which is the measuring unit of the force. And then for mass, which is kind of similar to the weight, but it's different, we're going to use kilograms. And then for the acceleration, we're always going to use meters over seconds to the square. So you will always be using these units if you're willing to use Newton's laws of movement. So let's get to the first law of Newton, which is the law of inertia. This law states that unless a force is applied to another object, it will remain the same at its resting state. Or if it is in a constant movement, unless you apply a force to that constant movement, it is going to stay the same. Now we have the second law of motion, also known as the law of movement, which states that the acceleration that a body acquires is proportional to its force and inverse to its mass. And that's where the formula comes from. The force is equal to mass times acceleration. And now we finally have the third law, which is the action-reaction law, and it states that by every applied force there's a reaction force for it. So for example, if I have a chair and I push it forwards, it's going to have a reaction force backwards to me. So now that we know the 3 laws of physics, I'm going to give you a quick example using real-life situations by pushing a chair and checking its time. Okay, so with the information I retrieved, I can now get the force that I applied to the chair while I traveled the distance. So I traveled a distance of 1.80 meters, and with my chronometer I determined that it took me 3.58 seconds to get to the 1.80 meters. And then I weighted the chair so it gave me 5 kilograms approximately. So now we just need to use this formula, which is force equals to mass times acceleration, which is based on Newton's second law, to get the force. So first, we don't have an acceleration, but we can get it by this formula, which is equal to final velocity minus initial velocity over time. So how do we get velocity? Well, velocity is just as simple as velocity equals distance over time. So I have the distance and the time taken, so I just divide 1.80 over 3.58 seconds, and I'm going to get 0.502 meters over second. So now with this I can get the acceleration, because with my initial velocity at the start, when I started counting the time, it was 0, so it just eliminates. Now I'm just remaining with the final velocity over time, which is this one. This is the final velocity. So I just divide 0.502 meters over second by 3.58, which is the time it took me, 3.58 seconds, and it is going to give me acceleration equals to 0.14 meters over second to the square. So now I have my acceleration already. Then what I just have to do is use Newton's formula, which is mass times acceleration. The mass is 5 kilograms, which is the weight of the chair, and then the acceleration, which is 0.14. And just by multiplying this, I can say that the force that I applied was equal to 0.7 newtons.